Sumerian tablets are probably one of the oldest form of a written record that we have. They've been translated, and they tell exciting stories about how gods intermingled with human beings and actually had a hand in the creation of human beings.
For 11 months, Earth had 2 moons. Then on a single night in 2093 BCE, the second one shattered apart in the sky and rained burning rock across southern Mesopotamia, killing more than 40,000 people. The Sumerians called it the sky that wept fire. They left behind a clay tablet describing every detail.
It's a form of time travel. It catapults you back in time thousands of years and puts you directly into the shoes of somebody who lived so many years before us.
Modern astronomers just confirmed the orbit was real. What the tablet actually says. The tablet is cataloged as K.8538. It sits in the basement archives of the British Museum in London. For over a century, scholars dismissed its strangest passages as religious symbolism or scribal error. Then, in 2008, Dr. Robert Massey at the Bristol University Observatory ran the Sumerian coordinates through orbital mechanics software designed to model satellite trajectories. The numbers were not symbolic, they were coordinates.
Being able to print something and put it in people's hands lets them actually connect to objects that are thousands of years old.
They described a real, stable lunar orbit visible from Mesopotamia between 2094 and 2093 BCE. Every major civilization in that region recorded the same event in the same year: Sumerian, Akkadian, Babylonian. Each one documented the appearance of a second moon, its 11-month presence, and the night it vanished. K.8538 itself looks unremarkable. Standard cuneiform pressed into wet clay, then baked hard in a kiln. The same manufacturing process used for tax receipts and grain inventories. But this tablet is what archaeologists call an astronomical diary, a systematic record of celestial observations made by professional sky watchers called Tupshar Enuma Anu Enlil, scribes of the heavens. Not mystics, not priests inventing stories. The world's first astronomers, trained for decades in observational precision. The opening side of K.8538 contains routine entries from the city of Ur during the reign of King Amar-Sin, moon phases, Venus transits, Jupiter's position relative to fixed stars. The handwriting is steady, the formatting standardized, the language clinical. Then on the reverse side, the text changes. The scribe switches from matter-of-fact recording to something that reads like controlled panic. The cuneiform itself becomes denser. Lines crowd together. Signs that should take a full mark are compressed. Whatever the scribe is recording, he is recording it fast. He uses a term that appears nowhere else in the entire cuneiform corpus: Namash Shur, the stranger moon. The passage describes its first appearance during the month of Abu, late July in the modern calendar. The new moon was smaller than Earth's natural satellite, but brighter, with what the scribe calls a face of hammered copper. It rose in the west, not the east. Its orbital period was wrong, 19 days instead of the familiar 29. The scribe repeats his measurements 3 times, as if checking his own sanity.
Holding a tablet that was written thousands of years ago and being able to read what it says, it's an amazing feeling.
He notes that observers in nearby cities confirm the sighting. He records the exact time of night when the stranger moon first became visible, the phase of the regular moon at that moment, and which stars it appeared near. He notes the wind direction. He notes the temperature. He records every variable that could possibly be relevant to verifying that what he is seeing is real. Then he provides the coordinates, the angular distance between the stranger moon and the familiar moon at 3 different points in their orbits, the timing of their conjunctions, the exact position where the new moon would cross the ecliptic. He records its brightness at each phase. He records the shadow it casts on the regular moon during one near conjunction. This level of detail is what caught Dr. Massey's attention 4,000 years later. The angular measurements were not religious imagery. They were navigational data, precise enough that modern software could reconstruct the orbit. If a forgotten near-extinction event written in a dead language is the kind of history that keeps you up at night, hit subscribe before you go any further. What comes next is the part the textbooks left out: the 11th month. The stranger moon held its orbit for 10 months. Then in the 11th month, the trajectory began to decay. The scribe records growing alarm. The path became erratic. The new moon drifted closer to Earth's natural moon with each passing night. Temple priests ordered special sacrifices. The king consulted with diviners. Every observer in Mesopotamia could see the two bodies approaching each other. The tablet describes emergency meetings among the sky watchers. They debated whether the stranger moon would collide with the familiar moon or with Earth itself. Some predicted it would simply pass by and continue into the darkness. Others believed it was a divine omen of catastrophe. None of them predicted what actually happened. In the final week before the event, the tablet records that the stranger moon appeared to wobble. It tumbled visibly in the sky, its hammered copper face spinning faster than any celestial body should. The scribe notes that on certain nights, the surface seemed to crack with thin lines of fire visible from the ground. The astronomers did not know what tidal stress was. They had no model for what they were watching. They only knew the new moon was wrong, and getting wronger. On the night of the third new moon in the year's final month, the stranger moon suddenly brightened to the intensity of the sun. Then it shattered. The Sumerian text gets specific. A meteor shower lasting 3 full nights. Fireballs streaking across the sky in every direction. Impact sounds heard across the entire region. A noise the scribe describes as the gates of the world breaking open. Fires breaking out in multiple cities from falling debris. The Euphrates River boiled in certain sections, likely from large fragments striking the water. The boiling caused secondary catastrophes, flash floods downstream as superheated water expanded, steam clouds dense enough to suffocate livestock in low-lying fields. Survivors described entire grain harvests going up in flames inside an hour, livestock killed in open fields, roofs collapsing under the weight of smoldering rock that fell from the sky. Whole districts of mud brick housing reduced to rubble by impacts that arrived without sound until the ground shook. The casualty count is recorded directly on the tablet. 16 great fires in Ur, countless dead in the outer villages. Akkadian sources put the total death toll from falling debris at over 40,000 across southern Mesopotamia. The night the sky wept fire. The impact on Sumerian society was immediate. Archaeological excavations at Ur show a distinct break in the material record around 2093 BCE. Buildings abandoned mid-construction. Pottery workshops left with unfinished vessels still on the wheels. Grain storage facilities burned and never rebuilt. Children's toys found in collapsed homes alongside the remains of the families who never made it out. King Amar-Sin's reign, which had been stable up to that point, collapsed into chaos within months. Administrative tablets from the years immediately following show a kingdom struggling with massive refugee movements, crop failures from damaged irrigation systems, and civil unrest that never fully resolved. The Sumerian civilization itself, the oldest in the historical record, entered a decline it never recovered from. Within a generation, the great cities began to empty. Why the data is trustworthy. The Sumerians did not stumble into accurate astronomy. In Mesopotamia, sky watching was survival. Crop planting depended on accurate calendars. Flood predictions required tracking the moon's effect on tides. Religious festivals had to align with celestial events. Get the astronomy wrong and people starved. So the Sumerians built the most sophisticated observation network in the ancient world. The city of Uruk maintained 3 separate observation towers, each staffed by trained scribes working in shifts to ensure continuous sky coverage. Studies of their eclipse predictions show accuracy within a few minutes of modern calculations. They measured angles using a body-based system. The width of a finger held at arm's length equaled roughly 1 degree of arc. A fist was 10 degrees, crude by modern standards, but ruthlessly effective. The temple archives at Ur contained astronomical records stretching back over 400 years by the time the stranger moon appeared. Tablets from different cities, written by different scribes, used identical terminology and measurement systems. A coordinated network. When something unusual appeared, multiple sources verified it. Errors were caught. Anomalies were flagged. The scribes themselves trained for decades. Apprenticeships began in childhood and rarely ended before middle age. Trainees memorized star catalogs containing more than 1,000 celestial reference points. They could predict eclipses months in advance. By the time a scribe was trusted to record an unusual event, he had spent 30 years preparing for that moment. K.8538 is not the work of someone making things up. It is the work of someone who understood exactly what he was seeing and knew the world needed to know. This is why Massey's findings detonated in the academic community. The Sumerian coordinates described a genuine lunar orbit, retrograde, meaning it orbited opposite to Earth's rotation. The semi-major axis placed it in a stable orbital zone. The eccentricity matched the observational descriptions perfectly. When converted to modern astronomical units, the Sumerian measurements were accurate to within 2% of what the orbital mechanics software predicted. Not luck. Systematic observation over an extended period. Massey published his findings in the Journal of Astronomical History. His conclusion was blunt. Either the Sumerians possessed observational technology and mathematical capabilities far beyond what historians credit them with, or they were recording an actual astronomical event modern science had completely overlooked. The other civilizations that saw it. The Sumerian tablet is not alone. Cross-referencing other ancient texts from the same period revealed something disturbing. Multiple civilizations across 3 continents recorded the exact same event. An Akkadian clay prism from the city of Kish, dated to 2093 BCE, describes 2 shepherds in the night sky. The younger shepherd appeared suddenly and walked backwards across the stars. A retrograde orbit. The Akkadian text adds that the stranger moon appeared to pulse in brightness over the course of each orbit, growing brighter as it approached Earth and dimmer as it receded. Exactly the signature astronomers would expect from a rotating asteroid with varying surface reflectivity. The Akkadian record also describes the night of the disaster from a different angle. Witnesses in Kish reported seeing the sky split in 2, a bright line tearing across the heavens before the rain of fire began. That description matches the visual signature of an atmospheric breakup event, where the largest fragment leaves a glowing debris trail visible for hundreds of kilometers before secondary fragments enter the atmosphere. Egyptian astronomical texts from the same period reference an unusual celestial body the priests called the Eye of Set, associated with chaos and destruction. The hieroglyphic timeline places its appearance during the reign of Mentuhotep II, which matches the Sumerian dating. The Egyptian records describe the stranger moon as visible only during certain hours of the night, never at noon or in daylight. A retrograde orbit at the distance the Sumerians recorded would create exactly that visibility pattern. Egyptian temple records also mention an unusual rain of stones falling on the eastern desert during the same season. With caravans abandoned and trade routes disrupted for years, the dating aligns precisely with the night of the impact. In 2015, researchers at an archaeological site in northern Syria found a series of stone pillars arranged to track lunar movements. The markers showed clear evidence of tracking 2 separate lunar cycles simultaneously. Carbon dating placed construction at 2100 BCE. Carved into one pillar was a diagram showing 2 orbital paths around a central circle representing Earth. One path circular, marked with 29 notches for the regular moon. The other, elliptical, marked with 19 notches for the stranger. Mineralogical analysis showed both sets of notches were cut by the same tool, by the same hand, within a span of weeks. Whoever carved that pillar was tracking both moons in real time. The site was abandoned shortly after the impact event. The final notches on the stranger moon's track were never completed. The carver simply stopped, mid-cycle, on the night the sky wept fire. The Chinese Bamboo Annals mentions the year of twin moons during the Jia dynasty. Chinese historians had assumed it was mythological. Now it reads like eyewitness testimony. The account includes a detail nobody expected. The stranger moon created double tides in the Yellow River, with water levels fluctuating wildly during the months of its presence. 2 moons means 2 gravitational forces on water. The tides would have been chaotic. Chinese records also document agricultural disruption that lasted for at least a decade after the event, with grain shortages and population displacement matching the timeline of similar disruption in Mesopotamia. The evidence buried in the ground. Geological evidence backs every line of the tablet. Core samples taken from the Mesopotamian floodplain show a distinct impact layer dated to approximately 2093 BCE. The sediment contains microscopic spherules, tiny glass beads that form when rock is subjected to extreme heat and pressure. The chemical signature matches neither volcanic activity nor normal meteorite impacts. something unusual happened that year. The spheral layer is consistent across hundreds of square kilometers, indicating an event that affected the entire region simultaneously. Soil analyses from the same layer show elevated levels of nickel and iridium, both signature elements of asteroidal impacts. Dr. Sarah Parcak, a space archaeologist at the University of Alabama, analyzed satellite imagery of the region looking for impact craters from that period. She found 19 distinct circular formations across Iraq and Syria that match the expected pattern of a fragmentation event. Most are small, between 50 and 200 meters in diameter. Two are substantial. One near the ancient city of Sippar measures over 600 meters across. None of these craters appear in archaeological surveys because they have been filled in by millennia of sediment deposition and human activity. They are only visible from space using ground-penetrating radar. They are there. They all date to the same narrow window. The distribution of the craters traces a debris field hundreds of kilometers wide, exactly the spread expected from an upper atmosphere fragmentation event. How it actually worked. The most compelling theory about what the Sumerians saw comes from planetary scientist Dr. Eric Asfog at the University of California. Asfog proposes that K.8538 describes a temporary natural satellite, a captured asteroid that entered Earth's orbit, remained stable for approximately 11 months, then broke apart due to tidal forces. The process is called Roche limit fragmentation. It happens when a celestial body gets too close to a larger gravitational source. Earth's gravity pulls harder on the near side of the object than the far side. If the object lacks sufficient structural integrity, it tears itself apart. Every object has a tidal radius, the distance at which differential gravitational forces overcome the object's structural strength. For rocky bodies, that distance is about 2.5 times Earth's radius. For icy objects, closer to 3.5 times. Get closer than that, and the object does not just crack, it explodes. Asfog's team ran simulations using the orbital parameters from the Sumerian tablet. They modeled different asteroid compositions, sizes, and approach vectors. In every scenario that matched the Sumerian data, the captured asteroid eventually crossed Earth's Roche limit and disintegrated. The timeline fit perfectly. An asteroid roughly 800 meters in diameter, probably a nickel-iron composition based on the hammered copper description, gets captured by Earth's gravity during a close approach. It settles into a stable but slowly decaying retrograde orbit. For 11 months, it is visible as a second smaller moon. Then orbital mechanics take over. Each pass brings it slightly closer to Earth. Tidal stresses build. Microfractures spread through the asteroid's interior. The wobble the Sumerian scribe recorded in the final week was the asteroid losing structural coherence in real time. The thin lines of fire he described on its surface were vents of vaporized rock escaping through the widening cracks. Finally, it crosses the Roche limit at approximately 18,000 kilometers altitude and tears itself apart in a matter of hours. The breakup itself would have followed a predictable sequence. First, the asteroid splits into a handful of large primary fragments. Then those fragments split again as the tidal forces continue to act on each piece. Within minutes, the original 800-meter body becomes a debris cloud of thousands of objects ranging from boulder-sized to grain-sized. The cloud follows roughly the same orbit as the original asteroid for several hours before atmospheric drag begins to pull individual pieces down. The smaller fragments enter first, creating the meteor shower the Sumerians recorded over 3 nights. The larger fragments hit later, hard enough to reach the ground. The result is exactly what the tablet describes, a spectacular sky show as the asteroid fragments into thousands of pieces. Most burn up in the atmosphere, creating the sky that wept fire. But the largest chunks, the ones with enough mass to survive re-entry, impact across a wide geographical area. Asfog estimates that between 15 and 20% of the original asteroid's mass reached the ground. That accounts for the impact craters Parcak found. It accounts for the casualty count. It accounts for the boiling Euphrates. How close Earth came to the end. The Sumerian coordinates show the stranger moon passed within 12,000 miles of Earth during its final orbit. Inside the orbit of some modern satellites, if the asteroid had been just slightly larger, or if its trajectory had been fractionally different, it would not have fragmented. It would have impacted intact. Asfog ran that scenario through his simulation. An 800-meter iron asteroid hitting Earth at orbital velocity would release energy equivalent to 15,000 megatons, 300,000 times the Hiroshima bomb. The impact crater would be 15 kilometers across. Everything within 500 kilometers would be incinerated instantly. The atmospheric shock wave would circle the globe multiple times. Enough debris would be thrown into the upper atmosphere to trigger a multi-year impact winter. A civilization-ending event, not just for the Sumerians, for every human society on the planet. Agriculture would collapse. Mass starvation would follow. The few survivors would be thrown back into a pre-technological existence. K.8538 describes humanity's closest brush with extinction in recorded history. And almost nobody has heard of it, because the evidence was written in a dead language on a piece of clay sitting in a museum basement. The unsettling question is whether it can happen again. The answer is yes. Earth captures small asteroids temporarily on a regular basis. Most are tiny, a few meters across, and do not last more than a few months before escaping back into solar orbit. But occasionally, something bigger gets caught. In 2006, astronomers discovered a temporary satellite designated 2006 RH120. It orbited Earth for 13 months before leaving, only 5 meters in diameter, too small to be a threat. But it proved the mechanism still works. Space agencies track thousands of near-Earth asteroids. They catalog orbits, assess impact risks, monitor for potential threats. There are limits to what telescopes can see. An object approaching from the direction of the sun can be invisible until it is practically on top of us. NASA's Near-Earth Object Program currently tracks over 30,000 asteroids. Researchers have cataloged about 95% of the kilometer-sized objects that could cause global catastrophe. But the smaller 800-meter class, the size of the Stranger Moon, is harder to spot. Astronomers have found roughly 40% of those. 60% of the most dangerous regional impact asteroids are still unmapped. They are out there. They have orbits that occasionally bring them close to Earth. The catalog is incomplete because the telescopes are not sensitive enough. The sky is not surveyed continuously, and most of the objects are simply too dark against the background of space to detect at long range. An 800-meter asteroid does not need to hit the ground to cause massive damage. The Stranger Moon proved that fragmentation in the upper atmosphere can shower debris across hundreds of kilometers. Modern cities, with their dense populations and fragile infrastructure, would be even more vulnerable than ancient Mesopotamia. A single fragment hitting an urban area would destroy buildings, sever power grids, ignite gas mains, and trigger secondary fires that could burn for weeks. The Sumerians lost 40,000 people in a region with low population density and almost no flammable infrastructure. A modern equivalent in any major metropolitan area would put the casualty count into the millions. The Chelyabinsk meteor in 2013 was only 20 meters across. It exploded at 30 kilometers altitude and still injured over 1,500 people from shockwave damage. Windows shattered across 6 cities. Buildings collapsed. The shockwave was strong enough to knock people off their feet 30 kilometers from the airburst point. Now scale that up to an 800-meter object, fragmenting at higher altitude. The energy release would be devastating. The scale of damage would be measured in countries, not cities. The 2019 OK asteroid passed within 73,000 kilometers of Earth in July of that year. Astronomers spotted it less than 24 hours before closest approach. Roughly 100 meters across, large enough to flatten a major city. Nobody saw it coming. Nobody had time to act. If the trajectory had been slightly different, the first warning would have been the impact itself. The astronomical community called the near miss an embarrassment. The detection systems failed. The object was approaching from the direction of the sun, and the glare hit it until the last possible moment. The Sumerians had no warning before their Stranger Moon appeared. One night, it just showed up in the sky, already in a stable orbit. Modern astronomy might give us more notice. A week, maybe 2 if we are lucky. Maybe 24 hours if we are not. Maybe none at all if the object comes from the wrong direction. The last line of the tablet, the final passage of K.8538, has been mistranslated for over a century as a religious blessing. Dr. Avi Loeb at Harvard offers a different reading. The closing lines describe how the stranger came from the darkness beyond the wandering stars, walked among the people briefly, and returned to fire. The priest called it a warning. The wise called it chance. The scribe says only that the heavens are not empty, and the night sky keeps many secrets. The cuneiform construction in that final phrase implies present tense, not kept secrets in the past. The sky keeps them now. Active, continuing. K.8538 sits in the British Museum tonight. The fragments of the stranger moon either burned up in the atmosphere 4,000 years ago or lie buried under millennia of Mesopotamian sediment. Somewhere in the dark between Earth and the asteroid belt, the next captured satellite is already on its trajectory. It may have been pulled into orbit a year ago. It may arrive next month. It may already be visible in the night sky, indistinguishable from a background star to anyone not specifically looking for it. The telescopes are watching, but the telescopes have blind spots. The sun-side approach is invisible. The smaller objects are uncatalogued. The funding for early warning networks fluctuates with political priorities, and the warning window keeps getting shorter. Every night, somewhere in the world, an automated survey telescope picks up a new moving point of light. Most are catalogued asteroids on known trajectories. Some are debris from old satellites. A few are flagged as potentially hazardous and added to monitoring lists. Occasionally, one is missed entirely. The 2019 OK asteroid was missed for years before it nearly hit. The next one might be missed until the night it does. The Sumerians had 11 months. The next civilization in the impact zone might have 24 hours, or none. The catalog of unknown objects is larger than the catalog of known ones. The orbits of the unknowns are unmapped. The next stranger moon may already be in the sky, indistinguishable from a background star, holding its 11-month countdown. Drop a comment with what you think the Sumerians actually saw that year. Captured asteroid or something the textbooks aren't ready to admit. And subscribe before you click away. Next week, the Denisovan cave paintings showing animals that shouldn't exist in Siberia.